Hello, my name is Guadalupe Bolaños, and my presentation will be over tight junction. So tight junctions were first visualized in 1963 by Palade at their ultrastructural level, which is just the fine structure of the cell that can only be observed through the use of a high magnification electron microscopy. And tight junctions are known to form watertight seals between adjacent animal cells. You can see them in the upper right corner in the image. And these tight junctions are held tightly against each other by clotings, which are proteins, to form groups. You see groups of tight junction proteins in the picture. And these groups are arranged into strands that form a branching network. And the more strands there are, the tighter the seal will be. So the two main purposes of tight junctions is to act as a fence that prevents the mixing of membrane proteins between the apical and basolateral membranes, and to also act as a gate that controls the paracellular passage of ions and solutes in between cells. So the different proteins that I was able to look up that take part in tight junctions is one of them is the transmembrane proteins, and these are your occludins and your clotings, the one depicted as blue and red in the image you see here. And these form the core of your tight junction, and they control the ion selectivity and the permeability of paracellular pathways for your cells, for your epithelial cells. The second proteins were cytoplasmic scaffolding proteins, your CO1s, 2, and 3. The 3s weren't depicted in this image, but they're usually closer to your actin. And so these proteins link tight junctions to actin cytoskeleton and the adherens junction. So your clotings are actually critical barrier proteins, and they are part of the clotting family. And just like the occludins, they too comprise a tetraspan transmembrane protein with 2 extracellular loops that you see in the image, and they directly regulate the gate function of the tight junction. And occludins are localized through phosphorylation in both epithelial and endothelial cells. And these proteins are usually regulated by kinases and phosphatases. And your COs 1, 2, and 3 are directly binded to your occludins. So tight junctions, we already know the two main functions of them. So they are usually found in epithelial cells, or found involved in epithelial cells. And one example that I chose was the mammary gland. And so the tight junctions of the alveolar epithelial cells are impermeable during lactation. So tight junctions allow the milk to be stored between nursing periods without leakage from the lumen. The only time where you will find leakage is when the person is pregnant, but this usually closes or seals itself up around parturition, which is just the time around birth. And the tight junctions are dynamic and can be regulated by a number of stimuli such as milk stasis, high doses of oxytocin, mastitis, and these basically increase the permeability of the tight junction. One disease that I found related to the malfunction of tight junctions is diabetic retinopathy, which is just basically leakage of your blood-retinal barrier, and this is most often due to vascular endothelial growth factors that are induced by glyceraldehyde conjugated advanced glycation end products. And so these growth factors basically make the tight junctions highly permeable, but they can also cause the receptors to disease that can cause these barriers to be less permeable in astrocytes. And also there was something RAR alpha that reduced the growth factor expressions in astrocytes, which decreased the leakage. And this actually was a target that they suggested that should be looked into, targeting the astrocytes to try to decrease the leakage or just stop it by possibly maintaining the impermeability of the blood-retinal barrier. But they would most likely like to target the earlier stages of diabetic retinopathy disease instead of the later ones, because it is much more harder as the growth factors make the endothelial cells highly permeable. So my question for you is there any way that we could possibly study the levels of phosphorylated tight junction proteins like the SO1s, 2 and 3s, or occludins or claudins? Can we visualize them as we have learned throughout this course, the different tests that they have done? Thank you.